Okay, getting down to the end. This lesson and 2 more to go and we'll be done with the course. This is 8.6a and the name of this section is the binomial theorem. And what we're doing here is we're taking binomials such as x plus y, putting them in parentheses and adding whatever exponent we want. So let's say we add a 5. And rather than multiply this times itself 5 times, or do the FOIL method, all of those times, there are formulas that we can use in order to solve this. And under binomial coefficients, it gives us basically 3 rules. We're just going to look at the first 2 especially. It says the exponent of the first term and the last term are the same as the power on the binomial. Okay, so the last term will always be the second one to this power, and the first term will be the first one to that power. Okay, and they are also equal to the sum of the exponents on every term. So when we put a plus sign here, and we have all these terms in between, when we add up the value of the exponents, they will always equal 5. And, oops, I said equal 5, and I went ahead and wrote 5 there, didn't I? Should be a 2. Now see what's happening. My exponents on my first term are going down, and my second term are going up until I get that. So I end up going 5, 4, 3, 2, 1, 0 x's, 0 y's, 1, 2, 3, 4, 5. Okay, so that looks pretty easy. The only other part to this is finding out what coefficients are going to go in front of each of these terms. And they give you a pattern for the coefficients using Pascal's triangle, which we are not going to end up using. We can, but there is an alternative method that is especially useful, especially when this exponent here is huge. I mean, you can use Pascal's triangle for the numbers here that are smaller, but when this number is like 47, you're not going to want to make a Pascal's triangle. And there's an example of one in the middle of page 637 if you want to see what one looks like. That would not be fun in order to do that. So, we have a certain method in order to do that, and that includes using factorials. Now, if you have not used factorials, or if it's been a while, let's just do a little bit on factorials. They're very simple, not difficult at all to do. And a factorial, basically, it looks like this, an exclamation point. And all that means is 5 times 4 times 3 times 2 times 1. Not times 0, because it'd make everything 0. And you should have a key on your computer or your calculator that looks like that. So you put the 5 in there, and then you hit the X with the exclamation point, and it will give you, for this particular one, is that 120? 5 times 4 is 20, times 3 is 60, times 2 is 120. Okay, so that's pretty much all there is to it. Now when we have a 2 factorial times a 3 factorial, that means 2 times 1 times 3 times 2 times 1, which ends up giving me 2 times 3 is 6 times 2 is 12. Alright, so you can just also write 2 times 1 times 3 times 2 times 1. And obviously, the 1 isn't going to change anything, so the only thing you're really multiplying are those. Now, part F on example 1 has one that's a little bit different. It's not tricky at all, but it's just a shortcut. Okay, so this is 6, 5, 4, 3, 2, 1. And this bottom is 4, 3, 2, 1, and 2, 1. Now notice, I can cancel 1, 2, 3, 4, 1, 2, 3, 4 there. So all I have is 30 over 2, which is 15. So that makes it easy. So rather than write all of this out, I can just look here and say, okay, I've got a 4 factorial here. Up here, I have a 6 times 5 times 4 factorial here. So I'm going to cross that out and cross that out and not even worry about it. And I'm just going to multiply that over 2, and that's going to give me my 15. It's just a lot easier that way. Okay, so we do have a handy-dandy way to find the coefficient of an expansion. So let's say that we have x plus y, and our exponent is just some number. Let's put n up there, meaning it can be any number. That is going to be equal to, okay, that is going to be equal to n factorial over k factorial times n minus k factorial. Okay, so what does that look like when we actually try one of these? Well, let's try x plus y to the 7th power. Alright, so what they're interested in us doing is they're not interested in us writing this whole expansion out. They are wanting to know what number is in front of x squared y to the 5th. If we were to write it all out, what number would go right here in its place? Okay, notice 2 and 5 equals 7, and we are, one of the things to pay attention to is how far down the line are we? Okay, so we know we have an x here and a y at the end. Okay, and we know that we are going to start with 0 y's and then have 1, 2, 3, 4, 5, 6, 7 y's at the very end. Okay, so we start out with 0 and we're going to have 7 at the end. Our x, we're going to start out at 7 and we're going to have 0 at the very end. So 1, 2, 3, 4, 5, 6, 7, 8 terms here. So it's going to be one more than what you're being asked to find. And this will always add up to the number and the exponent. So where does this one go? This is actually 0, 1, 2. There's where my x squared is going to go. So it's going to sit here. Doesn't really matter. You don't need this information in order to solve this, but I'm just trying to explain it, and we're looking for the number that goes in front of there. Okay, so this is how you do. This is how you find that number using this here. Okay, so our n will be whatever our exponent is. Okay, and then we have to look at our k and our n minus k. I do know that these two numbers are going to add up to be 7. And I know that we are looking for this term right here. Okay? So, where do we get the k and where do we get the n minus k? Well, this one's an easy one because this is going to be 7 minus whatever k is. Alright, so what is k? K will always be the exponent of the y term. So the y term is 5. And so the 5 is going to go there as well. So this then is going to be 7 factorial, 5 factorial, 2 factorial. Now remember what I said about this here. Let's see if we can get rid of some of this junk here. Alright, so I'm going to get rid of this 5 factorial, which means all I have is 7 times 6, and I had 5 factorial, but I cancel it with this one here. So that leaves me 7 times 6 over 2 equals 21. So the 21 is the number that goes in front of that. Okay, let's try another one. See if I can get rid of some of this without getting rid of everything. I want to leave our formula. Let's just highlight this formula that we're using right here. Alright, so let's look at B. They want to find out, still we're using x plus y to the 9th power. Okay, so we're not using that one anymore. Alright, what we're looking for is the coefficient to x to the 6th, y to the 3rd. Alright, so using this formula here, my n is 9 factorial, over, okay, my k is going to be 3, and my n minus k is going to be 9 minus 3, which is 6 factorial. Alright, so again, I'm going to cancel this with 6 factorial. And so now all I have left is 9 times 8 times 7 over 3 times 2 times 1. So 9 times 8 times 7 over 3 times 2 times 1. Okay, so when I do that, I can pretty quickly and easily get 84 for my answer. Okay, and those of you that are used to canceling, you would do that, and that makes it a lot easier. 12 times 7 is 84. Okay, so that's example 2. Let's keep going and talk about the binomial theorem for a minute. In fact, I'm going to stop this video here since we're at 12 minutes and make a B.